So this, it turns out to be our 23rd monthly building electrification webinar. We're slowly helping to launch electrification in New Jersey of our New Jersey homes. And tonight's guests are two owners of New Jersey townhouses, which is the wrinkle we have tonight. We have Bob in Red Bank and Tony in Howell, and they're going to describe what each wanted to achieve, their interaction with HVAC contractors, their discovery of limits to what they desired, and the final outcome, which was success in heat pump installation. And tonight, we welcome the return of special guest, Scott Nelson, owner of Oceanside Services. He impressed me one time when he told me he had 35 or so trucks, and I just envisioned all those trucks providing the installation and services for the several central New Jersey counties that he takes care of. Scott is up to speed on HVAC technologies. He serves on the board of the professional ACCA organization, which writes the standards, trains the service professionals, and fights for their interests in Washington. Scott told me that technology changes rapidly. Maybe twice per year, there is notable improvements in the things he installs. Scott features Daikin HVAC equipment. Daikin is the leading manufacturer in the world. But Scott said that he will install other manufacturers' products if requested. So Scott, I just gave you a little plug for your services tonight. Thank you.
Thank you.
So Scott's going to detail the heat pump solution he installed in Tony's townhouse. And he'll describe potential limitations of townhouses and discuss the HVAC industry that he knows very well now in his board responsibilities. And they respond to customer requests to help them electrify, and they respond by installing heat pumps in their home, among other things. So the second half of the program will be similar but different. You'll find it. It features my friend Bob. He purchased his Red Bank townhouse, I think it was earlier this year. He had lofty ideas of electrifying everything.
Yep.
Then he encountered reality, but I'm going to let him tell his own story. That'll be the second half.
Thank you.
So my wife will try to ensure that all your questions get answered, and probably will tell us what to do here to get those answers.
Yes, I'm Pat Miller, and I think my job, besides admitting people, which I will do right now, is to watch the chat. And at the end, if you have a question, put it in the chat anytime during the program. And after all three speakers have told their stories, then we'll have questions to all or any of them. So please just put it in the chat and we'll handle them at the end. Thanks.
Thank you, Pat. So we're going to start with Tony, and he will describe his situation with his townhouse in Howell. And then we'll follow with a discussion by Scott, who provided the winning proposal, by the way, and install the heat pump in Tony's townhouse. So Tony, take it away.
Okay, thanks, Steve. Good evening, everyone. First, let me just say that I'm not very knowledgeable about heating systems, and that goes for a lot of things around the house. When I have a problem, I just try to deal with a company that's knowledgeable and has reps that I feel like I can trust them. All right, so I'm going to just give a narrative about what happened with my old furnace and why I went into, got a heat pump and what transpired as I got quotes and whatnot. And Scott can fill in technical aspects of it. So I have a townhouse in Howell. It's about 1,600 square feet, built around 1988. So my sort of incident started with I had routine maintenance, like a checkup done on my furnace. Okay, like cleaning the filter and whatever else. And I had it done with gold metal because I had a coupon for some money off, and I didn't know who else to deal with, frankly. So gold metal came in, they did the cleaning, but they said, bad news, the furnace is just about shot. It was 15 years old. And I had decided that after attending a number of presentations by the Millers and other people, I decided some time ago that when the time came to replace my furnace, I would get a heat pump. I made that commitment to myself. I really feel that we should all try to pitch in and reduce our use of fossil fuels. So I was really looking to reduce my use of gas. So I went into it thinking, I don't care if it costs a few dollars more. This is what I'm going to do, right? So I asked, since I have gold medal right there, I asked them, do they install heat pumps? They said yes, and they arranged for somebody to come out actually very quickly. They're an aggressive company. Somebody came out and gave me a quote, but it sounded really odd because the heat pump, they said the one they had, and they claimed to like really know about heat pumps. I found out that they really didn't know that much about, not the latest heat pumps. They said the one that they would install only works down to 40 degrees Fahrenheit. And I thought that was odd. And I questioned him and I actually said, are you aware of the latest heat pumps? And they kind of hedged on that a little bit. But, and the price was a little bit high. And they recommended, and we'll get into the technical parts of it a little bit, but given the limitations of my townhouse and the duct system and the electrical system, they said I need a hybrid system with a furnace for when it's really, really cold, and a heat pump for other times, which of course provides heat as well as air conditioning. But I thought since the gold medal quote seemed a little bit odd, it's a good time to contact Steve Miller, see what he thinks of the situation, get some thoughts and recommendations. I did that. Steve had a lot of good ideas, and he jumped on the opportunity. I was very thankful. He was very helpful. We exchanged a number of emails over the course of a few weeks. He said, yeah, the gold medal quote doesn't seem right. It's high, and the heat pump, they can work below 40 degrees. So I really need to contact someone else. And he recommended Oceanside and Scott Nelson. And I don't think, Steve, you didn't use Scott. I think someone you knew used Scott, right? Was that the way you got his name? Well, maybe that, we can come back to that.
Yeah, the answer is yes, through other people. Yes, Scott has been used by several people.
All right, so
I don't remember how we got introduced.
All right, so in the meantime, I got a quote from another company. And they didn't come out. I didn't want to spend a lot of time with them because I didn't know much about them. They gave me a ballpark quote. That was with Air Experts. And that quote was also a little high, but the odd thing about that company, they were extremely aggressive, probably even more aggressive than gold medal. They would call and email me several times a day. And I stopped answering the phone. And eventually I emailed them back and said, please stop. I'll contact you if and when I need to. I don't like it when a company's that aggressive. And I'll come back to this a little bit later. Let me just finish the narrative about what I did with the heat pump. I also have community solar through Arcadia. I started that several years ago. I don't know if it's 4 or whatever, but I'm trying to reduce my use of gas or any fossil fuel. So Scott came out and examined my system, and we had a long talk. He seemed very knowledgeable. He seemed very trustworthy, which in my mind was different than the other 2 companies I was dealing with. And again, his quote was for a hybrid system, but the heat pump he recommended would work well below 40 degrees, something like 30. It actually can work below 30, but are limitations that Scott can address. And the furnace that he was recommending for very low temperatures was very efficient, is very efficient, and would not use a lot of gas. So I thought about it for a while. I contacted Steve once or twice more, and then I thought, this is what I'm going to do. This seems like the way to go. So Oceanside, Scott's company, was able to send people over within about, I think it was about a week. And I was anxious to move on this quickly because another thing that gold medal did, I don't know how accurate this statement was, but they said since my furnace was so old and there were problems with, I think it was the heat exchangers, they said it could leak carbon monoxide into my house. And I do have a carbon monoxide detector, but I wasn't sure. That kind of thing just scares me. I don't know if that was just another way to get me to buy from them. But when I hear that, I think, well, I'm probably not going to deal with you guys. I do want a furnace, but a heating system, I should say, but not necessarily with you. So as I said, I went with Oceanside. The two installers were here, and they worked probably a little more than half a day on a cold day. Installed everything, got rid of the old stuff. I had an air conditioner unit that was about 9 years old. Got rid of everything, and everything works fine now. So let me just address one last thing. Scott said something that I thought was very interesting when we were speaking. He was explaining heat pumps to me, and we got into some other issues. And he explained that of the major HVAC companies in this area, quite a few of them have been bought out by private equity companies. And that kind of threw up a flag to me because of things that I've read, that they're very aggressive, very, very much just after profit and don't care that much about what's best for a customer. And I looked up a list of such companies, and I found out this Gold Medal is one of them. One of the companies I got a quote from, Air Experts, is one of them. And there's a number of others. I think, well, I'm not sure about the rest of them, but quite a few of the larger local companies. And I saw for myself that those companies are just not very customer focused. They just want to sell. They just want to make profit. And I really don't like doing business with companies like that. If I have any choice, I will not do business with them. I like companies that are just more customer focused, and often they are small to medium sized companies. So I think that's it for my story. That's kind of in a nutshell what happened. And again, Scott can address the technical aspects of it, but I'm happy with what happened. And it's really too early to say. The time frame of all of this was my furnace went on the fritz in early to mid-November, and I've had the heat pump. It's been installed for about 4 weeks now, but it's a little too early to say how much am I saving or that kind of thing. How much gas usage have I reduced compared to the prior year? I will be tracking that fairly soon. So that's my story.
Okay. Why don't we go on to Scott? There are a few questions, but I want to make sure we get through everything that we have. And Tony, if you can go off on mute now, and let Scott be the only one that's not.
All right, you ready? Good evening and happy holidays to everybody on the Zoom. So a little bit about Tony's situation. Tony's in a mid area of a townhouse development where he has people to the right and people to the left of him. So he's fairly insulated as far as heat loss and heat gain is. Tony's existing duct system, which is all encased in sheetrock, there's no accessibility to any of it except for the near duct system that attaches to the furnace itself. He had an existing 3-ton air conditioning system with a gas furnace, and as Tony mentioned, these private equity companies that are out there that have really kind of taken over my industry. I would say that there's probably 4 major players in that PE network, and they've bought up in Monmouth County probably 4 or 5 companies in the last few years, and their bottom line is their bottom line. They're not necessarily worried about selling comfort, selling something that's good for our carbon footprint. Maybe something that was interested interesting to the homeowner. They're really about trying to steer you to something that affects their bottom line. And what they seem to do is prey upon people that are aging and people that will be more concerned about, they all seem to lead with a quote unquote carbon monoxide issue. As I explained to Tony, when I went, his furnace wasn't about to fail or about to poison him with carbon monoxide. That was more of a attention getter for him. You know, that's why you should be wary of the $49 or the $69 heating system inspection or air conditioning system inspection when it comes to cooling time, because that's really just a vehicle to get them into your home to sell you something. So with all that said, when I went out to Tony's house, expressed his interest, as he said, about going to a heat pump. But the problem there is that his heating needs, as we got closer to the bottom of our temperature spread here in New Jersey, you know, we have very few days that are below the teens, but we do get you know, days and nights in single digits, and sometimes below zero from time to time. And a 36,000 BTU heat pump system just wasn't going to be enough to heat his house. Where I would feel comfortable knowing that Tony, when it's zero out, would be as warm as he needs to be. So I explained to him the options of us putting in a heat pump system that would require some backup electric resistance heat to help him through super low temperatures. And the difficulty that we had was his electric panels was on his second floor, and there was no way for us to get a circuit down to the air handler that would be in his mechanical room, which is attached to his back of his townhouse, without going through great expense and without getting approval by the HOA, the Homeowners Association. So we spoke about other options that would allow him to lower his carbon footprint as low as humanly possible. And we chose together a 97% efficient modulating variable speed furnace to provide him his secondary heat that would help him as we got down toward the 20s and the teens and the single digits. The problem with putting in too big of a heat pump on a duct system that can only handle barely handle 1,200 cubic feet per minute of air, which is what is needed to move 3 tons of air conditioning in the summertime. You could put as much as you want into it. The delivery is only going to give you that 36,000 BTUs that is available for that duct system through that 1,200 cubic feet per minute of air movement. So we came up with a price, gave him the options to be able to do that, and we were able to complete that in one day. We have his balance point, which is the separation from heat pump to fossil fuel, set at 30 degrees. And I explained to Tony that we can adjust that down a little bit colder if he needed to, but because he gets his electricity from community solar, his electrical needs will be very, very small. And the modulating furnace, when it's operating below 40% of the unit's ability, it's almost 100% efficient. So it's a very, very low carbon footprint fossil fuel device. And it goes from heat pump to gas furnace without Tony ever knowing it's happening. It's all done through setting up some information in the outdoor control board on that heat pump condenser. So some of the problems with townhouses is that not accessible ductwork, no ability to make that duct system larger. Literally, Tony can speak to this, but I don't know that there was 2 feet or 3 feet of exposed ductwork before it all disappeared in encased sheetrock inside the house. And also part of the problem when you retrofit an existing home, and if you need to go bigger with your heating needs, which mostly or generally, if you're dealing in a retrofit application, whether it be a townhouse or a single family home, your heating needs can be upwards to 2 times the cooling needs in a heat pump application. And our air conditioning system is truly a dehumidifier that drops temperature as a result of dehumidifying the house. So when you wind up with a system that's bigger for air conditioning because of the heating needs, you wind up having an issue with removing the latent heat, which is the humidity in the summertime. So you wind up with shorter run times in the summer, and we wind up with excessive humidity in the summertime. So it's a delicate balance when you're retrofitting an existing structure, especially a townhouse or existing single family house, going from a conventional forced air system with air conditioning to going to a heat pump. Up until just recently, there was no ability to put a cold climate heat pump on an existing gas furnace. Mitsubishi just came out with their cold climate heat pumps. Not across all the physical sizing that they offer, but I believe it's 3.5 and 4 ton will allow us to put a cold climate heat pump on an existing gas furnace and be able to really kind of throttle that heat pump down to much colder than 30, but that literally just hit the market in the last week or so. We've yet to put one in. We've done their many of their heat pump systems, cold climate heat pump systems, but yet to put one on one of their gas furnaces. So I think my house will probably be the guinea pig for replacing my existing air conditioner that's 15 years old, and we're gonna give it a whirl and probably do that for this winter, and I'll be able to report back at the end of the winter on how that worked out. But some of the things that you need to be concerned with when you're inviting somebody into your house to get a price to change out your system is that these PE companies, they want to sell the low-hanging fruit. They make the most money selling standard efficiency furnaces and standard efficiency air conditioning systems. Their sales team, most of them, didn't emanate from our industry. They're really truly to get you to spend the most money and be a little aggressive, as Tony had mentioned, and offer you a system and kind of give you the scare tactic at you're going to have a carbon monoxide issue and jeopardize the health and well-being of your family and yourself. So you have to be careful who you invite into your house, and you need to make sure that they do heat loss, heat gain calculations, and check on the duct sizing of your air duct system, and know that what you're going to get is going to deliver the heating BTUs that you require with a cold climate heat pump. The dual fuel, the hybrid, we all are familiar with hybrid cars. The dual fuel application will save Tony's heat pump condenser and make it last a little bit longer. An average life of a straight air conditioning condenser is about 12 to 15 years. Doesn't mean it can't last 25 plus, but that's the average life expectancy in our industry. A heat pump is closer to 10 to 12 years because it's running 8 to 10 months out of the year. So once again, doesn't mean that it can't last much longer than that, but the technology in inverter heat pumps is changing so rapidly. And as Steve mentioned earlier, that, as he'd said, that I mentioned to him that our industry changes 2, 3, 4 times a year. And as we get farther into the IRA, the Inflation Reduction Act, you're going to see a lot more changes from all the manufacturers. And the inverter technology, which is the system we put in Tony's house, which right now is probably 15% of every HVAC manufacturer's offerings. In the next handful of years will be 90 to 95% of their offerings as that technology advances. We just got the heat pump we put in Tony's house, the Daikin Fit, which is their slim platform inverter technology at a really aggressive price point. They just came out with their enhanced heat pump condenser, which is hitting the market in the next couple of weeks, which gets the system we have at Tony's house at 3.5 to 5 ton to about 80% of its capacity down to 5 degrees. So the system that Tony has would run, it'll run down to below 0. We just lose, as we get closer to 5 degrees and 0, we lose about 50% of that unit's capacity to heat his house. That's why it needed to be augmented with either electric resistance heat, which wasn't capable in Tony's situation, or with a gas or a propane furnace. So there's, if you're going to retrofit an existing house, it's all about the envelope. It's about windows, insulation, weather stripping. It's all of it. Because your existing gas furnace on your, or propane furnace, or whether it's perhaps oil, has a lot of extra BTUs built into that furnace. So it's not as critical to make sure that your furnace is sized enough, because if you already have central air, the size of the blower in that gas furnace is more than, that furnace is going to be more than big enough to heat your house. When you go to a heat pump, you need every BTU to heat your house. So you need to get into making sure that your ducts are sealed. So in an existing home where you can't access the duct system, you know, there's a lot of leakage on anything that's been built more than 5 years ago. Today's codes require that all systems are mastic, which is a sealant that goes along all the duct joints. And there's also what's called the duct blast test on anything that's new construction or renovation, if the duct system's in an unconditioned area. So it's very hard to find somebody that will do a duct blast test for you to find out if you have leaky ductwork, because there's not much money to be made in that. The construction code requires that every permitted addition or a new house, if the duct system's outside the actual envelope, be duct blast tested. Well, I can tell you that I don't think there's 4 municipalities in Monmouth County that require it. More are, but the people that went into duct blast testing 5, 6, 7, 8 years ago all went out, because it's low margin dollars as a business owner, and not a lot of pent up demand to have it done. But once the IRA really kind of hits full blast next year, it will become more prevalent. So we took the time this past year to get certified to be a duct blast tester. And I also have a secondary company called Air Doctors, which is an air duct cleaning operation. And so that end of our business got into duct blast testing. And also about, if you can find out how leaky your duct system is, you can have a duct blast test done, but also finding out how leaky your home is by a blower door test. And once again, there's not a ton of people that do that. There'll be more as we go forward, but we also have become certified to do blower door testing, just to be able to ensure that our clients are, or potential clients are getting what they deserve. There's also going to be third-party certification, which comes about as part of the IRA with the low and moderate income people that will get the bulk of the funding from the federal and state governments with the IRA. And so we took the time this past year, and it's very difficult to do. They don't give it to many contractors. We're the first company in Monmouth and Ocean counties to be Pearl certified. Pearl is something good that, Steve, you probably should look into. Pearl is about lowering the carbon footprint in everybody's home. So it's going to give you a kind of a whole home approach and lowering your carbon footprint. And Pearl's a very big player in this. They were the first to kind of bring it forward. And we just got Pearl certified in the last 8 weeks. So it's really going to kind of change the way that people look at their homes and look how they can increase the value of their homes, having it Pearl certified. So the heating and air conditioning aspect is one of many. Hot water heating, insulation, lighting, so on and so forth. So it's, you know, the long answer to all of this is that if you're going to think about going to a cold climate heat pump or a hybrid type system, is to do your homework, make sure that people that you're going to contract with have a true understanding of what it takes to to heat and cool a house using a cold climate heat pump or a hybrid system. And there's more than just myself out there. There's others, and but make sure you do your due diligence in looking at what's available to you as a consumer. So with that, if anybody has any questions they would like to ask.
Great. Thank you, Scott. I've been watching the questions. I was going to wait till the end, but there's some here that I think we should go ahead and answer right away because they apply to what you just said. First of all, just could you clarify what you mean by an inverter and what for the layman what that implies?
Sure. So most compressors in your traditional air conditioning unit and or older school heat pump were done by the compressors. Think of the car engine in your automobile. Most compressors are reciprocating or scroll driven. So very similar to a car engine. A reciprocating compressor has a small crankshaft, has a valve plate, has a piston. It's an electric driven vapor pump, pumps vapor refrigerant through the system. An inverter compressor is a very efficient DC voltage 3-phase compressor. So you take 208 or 230 volts, whatever comes into your house, and it's going to go into an inverter board that's going to convert that single phase AC current to DC direct current 3-phase power. And it's a very efficient electric driven compressor. And that does the best job, of transferring the heat energy that's available to you outside at a very, very low electrical usage. The major electrical usage in your air conditioning system and or your heat pump is the start and the stop. That uses the bulk of the energy needs. An inverter compressor loves to run at about 30 hertz, which is about 30% efficiency, 30% capacity of that compressor. It wants to hum along and keep a steady, constant temperature that you never notice that changes. The tagline for Daikin is imagine the air we share, which means it should become seamless to you, not knowing whether your heat is on or your cooling is on. It should just really kind of be a steady, constant temperature in your house. And this inverter compressor allows that to happen at a very, very, very low cost to operate.
So having that is an upgrade to not having it.
1,000%. So for example, the entire world except the United States uses inverter technology. Everywhere in the world except us. So about 10 years ago, because of lobbying from the energy companies, nobody offered a inverter piece of equipment. 10 or so years ago, they were all shamed into bringing inverter lines to each manufacturer. So they all brought them in at the highest SEER rating and the most expensive to purchase. So it really made it, cost prohibitive for many to afford to have something like that put in. And in today's economic landscape that we're all dealing with, it's even more difficult. Daikin entered it into a mid-tier efficiency model that really kind of set the industry upside down. So now our industry is very much a copycat industry. So everybody's been chasing their tails trying to catch up to the technology that Daikin has had. So that inverter technology is done with a communicating system, which means that the motor in the furnace or air handler, the thermostat, the electronic expansion valve, which meters the flow of refrigerant through the indoor evaporator coil in the summertime, and the metering device that's out in the condenser for heating side, and the compressor and the thermostat, they all talk to each other, and it creates a firing rate for the appliance that meets the needs of the house without you ever having to really ever think about adjusting your thermostat.
Okay.
Uh,
A
Pat,
couple of people asked this.
Pat, I think we should give Bob time because it's now 7:38. And
Can I
can
just
we,
add one quick thing? It takes a second. I forgot to mention it. Somebody asked, I put it in the chat, but of the three prices I received, Scott's company was the lowest of the three. It was actually several $1,000s lower than gold medal.
thank you.
Okay.
So Pat, I want to turn it over to Bob and then we can return to questions.
All right.
Put them in
Okay.
chat.
So
So
we'll
I
all
want to do,
mute.
yeah, so mute again. And Bob Morrow now is going to present his story, living in Red Bank. The end result, by the way, will be he does achieve the success of having a heat pump in his townhouse. So bear with him as he goes through his story.
Indeed. Okay, well, here, let me try sharing my screen. See if that works. Okay. 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 Like Tony, I'm a lay person. I'm not an engineer like Steve or an HVAC expert like Scott. I'm a retired U.S. history professor. And Also, though, I'm a member of Citizens Climate Lobby, one of the climate advocacy organizations that both Steve and Pat uh, are members of. And so as a result, I come at this question very strongly from wanting to do my part for fighting climate change, and not so much for the way it's sometimes sold, that it's about saving money. A little description real quick about our house. Last spring, we bought a townhouse in the Elkridge community in Red Bank. And I'll go into more detail about the house. But when we bought it, I hoped to sort of create a model electrified home in the process, because I had done some research. I'm nowhere near as expert as Scott and Pat and Steve, but I had done some research with Rewiring America, the website that focuses very strongly on home electrification and on what subsidies people can get from the Inflation Reduction Act for improving their homes and cutting their footprint down. And I tried to follow their stages, and I want to talk a little bit about that. I'm not going to go into too great detail about that because the focus here is really on the heat pumps, and so that's the part of the story that I will focus on the most. But the other thing to mention is that this is a condo, a townhouse, very much like what Tony was dealing with, wherein my wife and I own the inside walls, but the homeowners association owns the outside walls, and as you'll see in a few minutes, that becomes a crucial fact. Quick overview of my remarks. I want to touch on some first steps briefly. The purchase of our EV, the new electric panel we put in, and the car charger we put in. And then I want to switch to sort of beginning steps that Rewiring America and others have laid out, talking about creating a tight envelope, insulation and new windows and such, and then go on to heat pumps and talk more about heat pumps than about some of these other details, since I want to sort of stick to the topic at hand. First steps, in February of this year, we took delivery of a 2023 Chevrolet Bolt EUV, which I'll be honest, I just love this car. It's a blast to drive. And I want to throw out one lesson for all of the people who are worrying about range anxiety. There's so much talk about range anxiety with EVs. For most people, it's nonsense, because The average American drives their car about 30 miles a day. If you don't have a long commute, I did once have a long commute. But if you're not driving much more than that, it's very nice. You can just charge up every few days, every 4 or 5 days at home, in your garage, in your backyard, and you never have to go to the gas station. And the car is a blast to drive. So that's been great. Great. We did two things as well when we first moved into the house. One was to replace the electric panel because the electric panel that was in the house was a fire hazard and had to be replaced. And dreaming that I was going to turn this house into a fully electric house, we replaced it with a 200 amp panel, or rather a panel that would accommodate 200 amps worth of circuits. And when we did that, the electricians also put in an EV charger as well. And as you can see on my slide, we needed 200 amps if we were going to do everything, but we couldn't get it, and that's part of the story as we go here. And let me talk about that a little bit, because this illustrates a problem with at least some condo townhouses, and I don't know if this is true for Tony or for most of them, but it's certainly true in Elk Ridge. As was explained a couple of months ago on these webinars, the man explained how the electricity gets to your house. And in our case, there's a transformer across the street, a line that runs under the street to a meter bank. And in the case of these townhouses, we have townhouse blocks of homes connected together that are 4 or 5 or 6 or 8. And when you have that on the end of one of the townhouses, in our case, there's 4 meters all in a bank there. And the JCP&L power comes from the transformer to the meters, and JCP&L owns the line to the meter and the meter itself, and they give you 200 amps up to that point. But then there has to be some connections that will carry that power from the meter to the individual unit, individual home, and those are the responsibility, the ownership of the homeowners association. And in our case, they're 100 amp lines and cannot handle 200 amps. Well, then you'd say, well, okay, then just let's update the lines. And it turned out the board of our homeowners association was actually talking about some of their meter banks needing replacement. And I suggested they look into all of this, and suggested my electrical contractor who'd done our electrical panel. And the contractor came out and talked to them and said, well, there's a real problem here. Your lines that connect the meters to the individual homes run somewhere. They run under all the homes, under the foundations. They run through the foundations. They run around under the earth around them, or something. And there's no way to tell which way they put it. And I said, well, yeah, but hold it. There must be plans for building this place. Wouldn't that be in the plans? He said, well, yeah, it'll be in the plans, but you don't know that when they constructed it, they actually followed the plans. So you're going to have to do a big exploration to find them. And he says, that's bad enough, but what's worse is that your 8 home banks, where you got 8 banks, eight meters in a bank, and all 8 homes on those meters, the home that's at the far end of that row of homes is not going to be able to get power from that bank at the 200 amp level. There are too many bends, and the line's going to be too long. So you'd have to split the banks and have 4 meters on each end of this 8 home bank, and 8 row of 8 townhouses. And so it's going to be very expensive. And at that point, our property manager says, well, okay, so we're not going to be doing that. So there went my fantasies of 200 amps. We're going to have to return to that in a while. But when you see the end of this story, you know why I'm not going to be returning to that too soon with the board. Now on to the central things, the 2 central things I want to talk about. And this, as I say, well, I'll keep sort of short. a tight envelope. Scott was talking about this, and one of the first things that Rewiring America and lots of other people writing about this have said is that before you start turning to using these heat pumps, you want to do a couple of things to make sure the house is as tight as you can. Because as Scott was saying, you know, many homes with gas furnaces have lots of extra capacity, and so you know if the house leaks a bit, it's not a problem. But with heat pumps, you really want to have it tight because you don't have as much extra capacity. So you start with a home energy audit, which we did. The home energy audit was done by Seal Power in Kearney, New Jersey. And that includes this blower door test that Scott was talking about and some other stuff. And forgive me, I haven't mastered the technical details of that for the presentation. We don't have time anyway. But the other part of what we did right off the bat was replacing all the windows, because there were a lot of problems with this house when we moved in. The HVAC system was really ancient and really in bad shape, but worse was the windows. You couldn't open any of the windows. A lot of them, the seal between the two panes had been broken, and so there's all this moisture between them. You can't even see out the window. So we had to replace all the windows. So that aspect of creating a tight envelope we did right off the bat. And then after that, Seal Power came and did attic insulation and foundation sealing. And among the attic insulation, you can kind of see the picture. This is what the attic looks like. And as Scott was talking about accessing the ducts, you can see a lot of the duct work here you can access directly in the attic. They blew in 9 inches of cellulose insulation up in the attic, and did some other things to seal up the attic from losing heat up that way. And then this what to the layperson looks kind of like giant industrial caulking at the foundation. In any case, the results for the layperson just living in the house are subtle. It's not drafty at all, and the heat pump system that went in was working great in the fall. But as you guys say, that's not much of a test. There also is a post test to this, and they came back and did the blower door test and a bunch of other tests, and they've given me the results. And forgive me, with my wife's illness over the last few months, I have not gotten a chance to sit down with them and say, okay, explain all of this data to me, because I don't quite understand what it's saying. But my wife was reminding me that we were told that we were Pearl certified as a result. And that was something, a sort of selling point on the house later on when that time comes. But overall, my impression of the data is that there was significant improvement in terms of how tight the house was. Okay, so that's kind of preliminary to the main event, which is the heat pumps, and I want to take you through the story of putting in our heat pumps. Okay, our townhouse, as my slide here says, is a 3-floor townhouse with a 2-zone HVAC system, a complete 2-zone, wherein there are 2 condensers and 2 air handlers, or 2 furnaces when it was gas. And as a result, the way it's set up, the furnace, or now air handler in the basement, handles the basement's needs and the first floor living room, dining room, kitchen level. And then the heat pump, rather the air handler up in the attic, which was in the picture in the last slide, handles just the second floor, which is 2 bedrooms and 2 baths. So I got quotes from 5 different contractors along the way. And all along, I insisted I want a heat pump only system. I want to be done with gas heat completely. And I'm sitting here in a townhouse with only 2 outside walls. It's tightly sealed. I should be able to get by with cold weather heat pumps. And what I found with the 5 contractors I talked to, that only Arctic Air from Old Bridge just said, sure, we'll just give you a quote. They didn't say, well, you know, you really need to have a furnace as backup when it gets really cold. And so I went with their proposal. I had consulted with Steve about what the best manufacturers of ducted heat pumps were, and Mitsubishi was at the top of the list, and that happened to be what Arctic Air was offering. Okay, so our sales rep came in, measured all of the rooms in the house, and to our delight, we found out what the actual square footage of our house is rather than what Zillow thinks it is. And it's about 2,000 square feet, so it's a little bit larger than Tony's house. And he did a whole bunch of calculations on his computer trying to figure out exactly which model of heat pumps to use and all of that, and concluded that for the basement and first floor levels, we would have a 2-ton unit and a 1.5-ton unit for the attic. Okay, so the installation. The main installation of the system, 2 condensers and 2 air handlers, took 2 days, basically, with 2 or 3 men working on it. And that was Monday and Tuesday. And at the end of Tuesday, one of the systems was not working. And for the longest time, they were thinking it was the condenser out in the back that wasn't working. But in the end, after 4 or 5 more visits by a whole parade of different installation experts from the place, they figured out, with Mitsubishi's help, and so Mitsubishi was not able to solve this question either. Finally, a week after they had finished putting the system in, they found this tiny part in the basement air handler, so small that the part's smaller than my thumbnail, that was defective. And once that was in, it works perfectly. Now, one of the other things that I got, though, from Arctic Air that I did not get from anybody else was that the system was going to have a load control module, this little electrical box that is installed right next to our electric panel. And that's apparently a requirement of Red Bank Borough Code, but maybe other districts' codes, where you're operating with only 100 amp service, and you've got, we've got 2 condensers and 2 air handlers, and we've got a car charger. And what the load control module does is that in the case that you're running the car charger at night and the heat pumps are running at full blast, it will shut off the car charger when the load on the whole system gets too high. And in general, it seems to have been completely transparent. I was never noticing any time that the car didn't end up fully charged the next morning, except once. And I said, oh, what happened? I wonder what happened. And then it suddenly dawned on me. I was running the heat pumps, and it was getting a little colder at night. And the load control module probably shut off the charger. It wasn't a big problem, though, because it was mostly charged most of the way, and it wasn't a problem in the morning. Just plug it back in and get it going again. One last detail to add about this. We got a 10-year 0% loan from the National Energy Improvement Fund, which will be paying off to pay off the installation of the heat pumps. Okay, now we get to, in some ways, the most interesting part of the show. The heat pumps turned out to be a big problem with the homeowner association. I'll explain why. While the guys were installing it, they came to me and said, well, our refrigerant lines that have to run from the condensers in the backyard to the air handlers inside can't follow the gas lines that exist in this townhouse. It's tightly built, and there's just no way these lines can do the turns and everything that would be necessary. We're going to need to drill a hole in the wall. And what they wanted to do was drill a hole in the wall where the lines would pass underneath the drop ceiling in the basement and across to where the air handler is. And then for the air handler in the attic, the lines run up the void where above the furnace on the first floor is a fireplace, and so there's a void where the flue is for both the fireplace and the original gas furnace. And they wanted to run it through there, and I looked at it and said, well, at this point I have no heating and no air conditioning, and I need them. We better do it, knowing full well that the outside walls are not my possession. So they did, and you can see in the picture here, they took the coolant lines, the refrigerant lines, and ran and put them inside of this PVC conduits to sort of neaten it up and protect them. And so I thought it looked great, and I thought it was very nice. However, at one point, the property manager for the homeowners association was walking by, and she was shocked and furious. I'm inside working on something, and the guys are outside working on the installation. And suddenly I hear a familiar voice talking to the installer, and I say, "Oh my God, that's Cindy." And I go running out and I call her over, and she says, "Oh my God, I can't believe this. What are these things? They're huge. They're huge. Well, they look so weird. What are they?" I said, "They're heat pumps." "Well, but they don't look like air conditioning condenser." "No, they don't. They don't. They're heat pumps. It's a different technology." And if you knew heat pumps, they look like heat pumps. And she says, "Oh, but they're on stilts too. They're propped way up." Well, she had her teenage son with her, and her teenage son says, "Well, yeah, that's to keep them out of the snow." And I was frankly a bit tongue-tied dealing with this crisis. And I could only say, yeah, that's right. That's right. But anyway, and then she said, "Well, and this conduit, and you've gone through the wall. You're not supposed to do that, and when she calmed down a little bit, she and I talked about it, and she said, "Well, you could paint the conduit to match the wall, and that would help. And then we'll put some plantings here to shield these monstrous heat pumps from the view of people passing by on the walkway that goes down to the clubhouse and the pool." And fortunately, the board agreed with that. And so that's where it is at this point. Lessons for condominiums. Well, the contractor really needs to carefully consider the architecture of the home before bidding and installing. And in fairness, Arctic Air didn't do that. And I wish they had, although frankly, I probably wouldn't have ended up with a heat pump system. Because frankly, if I'd known that they were going to have to go through the wall and I'd gone to the board for permission, the board said in their official letter to me, well, we wouldn't have approved it. So that would have been sort of the end of my electrifying the home right there. And problems of electrical supply can be unexpected and very difficult to solve in a condominium kind of situation. Unlike a single family home where it's your electrical system, you can do what you want. And perhaps in the future, there will be additional subsidies from the federal and state governments necessary to help out condominium homeowners with some of that. And above all, the last lesson is the one we already know, which is remember to consult the experts like the Millers and like people like Scott and some of the other experts you've seen on these webinars. And at that point, I will stop so people can ask questions.
Okay, we have a lot of questions now.
Oh, okay.
I can't decide whether to start from the end or start from the beginning, but let's just see how far we could go. We want to end by 8:15, so that gives us 12 minutes. the question I was going to ask, and it's a good thing that we went ahead to Bob to get his story, was the question about the heat pump going down to 0 degrees or lower, and what if someone insists that they do not want fossil fuel backup, period. Bob, I think what you ended up doing is just saying, we'll take it as it comes.
Yeah, exactly.
And,
It works in
and
Maine. Why can't it work in New Jersey? No, and in fairness, our salesperson with Arctic Air was very clear that it's going to function quite satisfactorily down to 5 degrees. And my understanding is that 5 degrees is the low temperature standard for Newark Airport, for example. But he would also go on to say things like, well, and you still have heat at 20 below. Well, and I said to myself, frankly, people are going to have to adjust with climate change, with all due respect, folks. And I've got a lot of sweaters. I've got throw blankets. If it gets cool in the evening, I can handle that. Now, if it's going to go down to freezing the pipes, that's serious. But no one's talking about that.
I know Sean in California told us it's when it happens in New Jersey, it's going to happen during the night. So just turn on your electric blanket and you'll stay warm.
Yeah.
And by the time morning comes, it's going to be higher than it was in the middle of the night too.
Pat, can I hop in just for a second on that point?
Sure.
So, that's all well and good, but as somebody that sits in my chair, the litigious opportunity to not provide somebody with adequate heat opens up a whole Pandora's box. So you have to be able to think. I have to think that we have to be able to give somebody 70 or 72 degrees in their house when it's whatever the temperature is outside. And that's why you have to be cognizant of what you're purchasing, what you're putting it into. It opens up, the people that we're kind of preaching to the reformed here on this platform, but for others, they don't want to know that they're not going to be comfortable at whatever the outside temperature is.
There are a lot of people, though, Scott, who have setbacks. And I mean, I had a friend just telling me recently, you really should be. We go down to 65 at night because you sleep better when it's cold. And I don't know if that's true, and I don't think my wife's too fond of those kind of temperatures. But it is a kind of a contradiction to say, well, we want to use setbacks, but well, no, we don't. But I understand what you're saying. In your business, you're absolutely right. You've got to be able to give people exactly what they want. I'm just saying that for some of us, we're not out of our minds to consider the possibility that we might.
No, not at all. Just everybody needs to be understanding of.
Absolutely.
It's a completely different animal than a fossil fuel system, and a heat pump's really not designed to be set back. That's
no, and I wasn't suggesting I would do that, but I'm saying it would.
But the
get a setback whether you want it or not.
The layperson that is used to setting their heat maybe back to 60 or 65 when they sleep, or when they go to work, that when that heat pump is running at an inverter compressor, unlike a reciprocating or scroll compressor that I spoke about earlier, it's only designed to run up to 100%. An inverter compressor will run you up to 115 or 120%, depending on the manufacturer. But that's when it becomes super inefficient, when it's running full out. And its design is to run at something less than 100%, so that it's providing the energy efficiency, meaning the lower utility bill that we all strive to get. So it's a delicate balance when you're dealing with a homeowner, because the first day that it's 5 and their house isn't comfortable, who are they calling? They're calling somebody like myself, why didn't you tell me that? You know, so just
Oh, yeah. Well,
you need to be
and
cognizant.
Air Experts was very, very aggressive on this point. We do not want to quote you an only heat pump system, because you'll just be coming back to us next winter and saying, "Oh my God, you've got to fix this," and we don't want to deal with that. I mean, it was really obnoxious. It was really obnoxious.
They're
Yeah.
listen, they're a different animal,
Exactly.
you know, and
Exactly.
but yeah, just to make sure everybody is understanding that, if you're, you know, listen, every home is going to be different, whether it's a townhouse, a condominium, a single family residence, whatever it is, every house is unique to itself. So it
Yeah.
has to be treated as such.
And every customer is going to be different too,
Yeah.
for sure. Okay, I think we've pretty well covered the homeowners association. Someone asked about that early on, and I think Bob gave gave a pretty good overview of that. And Tony had already said that his price, Oceanside's price, was his lowest one. Um, so for both of you, how's the comfort level in your home with the new heat pump?
It's fine. It's actually better than with the old system. With the old system had larger swings in temperature. This one, the heat pump does run more. It runs longer than the old furnace ran, but it is quieter. And I guess one aspect of it running more is that I don't have large swings in temperature. I really don't feel. With my old system, I used to feel, I said, it's cold. The furnace is going to come on very soon because I feel it dropping, and it did. I don't feel that anymore with the heat pump. It is quieter too.
Yeah, that's by design.
I
It's
would
I
just
hear
supposed
it.
to
second
do
every
that.
bit of that.
That helps with the humidity also.
Yeah, I would second all of that. It's quieter. It probably is running a lot more, but boy, it was really steady. It never went beyond about a 2-degree range. It was marvelous. It'd be a degree high or a degree low. It was fabulous.
Pat, just
Yeah.
again to touch on that, it's that inverter compressor is truly meant to run all the time at a very slow speed, so you never feel that temperature change. And to Bob's pictures, the stanchions that his units sit on, yes, that is to keep them above the snow, but more importantly, it's to keep it from ice damming. So a heat pump is an air conditioner that runs, excuse my language, but ass backwards in the wintertime. And with that outdoor coil will tend to ice up. So that unit has to defrost, kind of like your household refrigerator and freezer will. They have a defrost clock that will put it in defrost. These heat pumps have a defrost mechanism in them. So when that happens, it goes back into air conditioning mode, and it heats up that outdoor coil, which melts the ice, and that water has to go somewhere. And that unit's running when it's below freezing out, so it doesn't ice dam. So as important as it is to have it up for snow, it's most important to have it up for ice damming. So it's very similar that if you have a direct vent gas appliance in your house that you want to clear it, if we have any blowing, drifting, tragic 3-foot snowstorms that we get seemingly every 10 years or so, you want to make sure if you have a cold climate heat pump or any kind of heat pump that you're doing the same. You're making sure that that doesn't get impacted if that condenser is in an area where you would have blowing, drifting snow.
Okay. Just to be clear, I guess, Susan asks, are there conditions in a house ever that make heat pumps not a viable choice?
Is that for me?
Yeah.
No, there's not. There's not. We changed 2 systems in Matawan that were actually 3 that were 30-year-old air conditioning systems that had older ductwork on a fairly newer boiler. The company that bought Air Experts also owns another company who have similar militant tactics to get you to purchase. And they were very militant with her. And she's older, and the house is from 1800. the early 1800s, you know, is an old converted farmhouse that had a series of additions put on. It was pretty drafty and leaky. So, you know, that would probably be the worst case scenario, but we were able to seal her duct system, put in 3 Daikin fit heat pump systems, and it takes care of about 80% of her heating needs. You know, she's got solar electricity, so she wasn't necessarily worried about them running a little longer than they should because of her drafty house. And she uses very, very little natural gas to augment the difference in her heating needs. So there's, once again, every house is a unique situation, but we haven't come behind any that couldn't have either a hybrid system or a straight heat pump system.
But you also underscored the issue that it always helps if you have a drafty house to seal the leaks and weatherize it.
Most paramount. If you're going to straight cold climate heat pump with no fossil fuel backup, it has to happen. It has to happen, or you'll be an unhappy consumer.
Yeah. Now, Frederick had asked, with the heat pump only system, what do you do during a power outage?
You have no heat.
And someone else said,
I'm
you
good
don't
for it.
have heat when you have a gas furnace, if you have a power outage either.
Well, yeah, that's just it.
So,
I
yeah.
mean, there are electrical components to a gas furnace as well. So
Right.
what you would have is hot water, though. No electricity there.
Well, no, not necessarily. Power vent water heaters, advent of direct vent appliances, you wouldn't have it either. Would have to be an atmospheric vent water heater, and they're like heat pump technology, whether it be water heaters or heating and cooling. Atmospheric vent water heaters are less and less being installed.
Yeah, yeah. That's why people have generators all around Middletown.
Yeah. Bob, here's a question. I think you already answered this, but do you have an electric heat strip backup? And I
No, I
think you
do
said
not.
you couldn't
We
do that with
carefully thought about that. We carefully thought about that. And you know, those have get a really bad name, frankly. And the truth is, I guess in some ways we're a second generation heat pump customer because my mother-in-law had a townhouse she bought in 1981, and it had a heat pump system of that vintage, and she used to keep that house at 55 to avoid the electric strip heat coming on, because that really jacked her bill, just like everybody tells us. So no, I decided to not do that.
Okay. Someone's asking how old your townhouses are. Now, Tony said his is 35 years old.
His is
The
1988,
person
mine is
that asked the
1986.
question says, I have a 68-year-old townhouse.
Yeah,
And Bob,
no.
you had said too, but I forget what it was.
1986. I didn't mention in the talk that it's 1986, so we're in very similar kinds of vintage. So you know, the house is built pretty nicely, and there's you know, in terms of the duct work, most of the duct work, a lot of the duct work is exposed, particularly all the stuff in the attic. The whole second floor duct work you can get at. The basement and first floor duct work, there's some of that exposed, but some of it isn't. So, but
Okay.
yes, it's same vintage.
All right. And Mary Rose is asking, are you saying that heat pumps should be set at a temperature and left there? Or is it okay to set them back 2 or 3 degrees?
Set it and leave it. Set it and leave it. You're gonna cost yourself more money and trying to recover that temperature, because you're gonna run that heat pump up to, let's say you normally keep 70 and you set it to 65 when you leave, or set it to 65 when you sleep. When you're trying to make up that 5 degrees, that is now going to take that inverter compressor and run that up to 100% or maybe beyond, and that's where you lose the efficiency in that piece of equipment. It's meant to just kind of hum along. And like, as I said earlier, it likes to run at about 30% or less capacity. And what will make that raise up is opening and closing of doors or windows, or, you know, bringing in groceries on a cold day where you're getting wind coming in, or, you know, letting children in and out. That's the only time that it'll really raise up. It'll really just want to keep it's really never going to change more than a couple tenths of a degree.
Okay. Here's a new one, I guess. Does a heat pump add humidity in the winter?
Ooh, that's a good question.
It does not. It does not dry out the air as much as a gas or an oil or a propane furnace will. And the reason that air gets dried out is because most pieces of equipment are 100% on or 100% off. And that's what dries the air out. By heating at a much slower pace, air doesn't become as dry. But still, anytime you heat air, you know, it will dry it out. And our cold snaps that we get generally come from the Northwest, and it's very, very dry. The humidity level is going to be very low. The best way to add humidity back in is a steam humidifier.
Okay. I think that's all the questions we have. There are many, many congratulations to the three of you for such good presentations. So thank you so much.
Thank you.
My pleasure. My pleasure.
My
It's always
pleasure.
great to serve this initiative. It's very important.
So thank you very much. I admit I say the same thing. I'd like to also thank those who attended tonight, and I'd like to invite everybody to attend our next webinar, which will be the third Thursday in January. We have a couple of people lined up. We have Ken Bilski in Parsippany, New Jersey, and ICS, which is the vendor that installed his heat pump, and they'll tell you after January, maybe we'll have cold weather, and they'll be able to tell you how it fared over winter. So thank you for joining tonight. I hope you have a joyous holiday and hope to see you in a month.
And let me just, one comment that is in the chat is that the tax incentives are available now. The rebates will not be available for another year. So if you had work done in 2023, you there probably will be, there may be tax incentives that you can put on your taxes. Just ask TurboTax or your accountant when you file early next year. But if you're waiting for rebates, they're not going to be available for another year.
Okay.
Okay. I think we're finished unless anyone has any concluding questions or comments.
I know of a person who installed heat pumps recently in Long Branch, and he said he's applying for his rebate of $1,200 now.
Well, there are state rebates that have been in effect, but not the IRA rebates.
Okay, so they're not available for this year?
Not the IRA rebates, but the state ones are in effect and will continue until they're replaced by the IRA.
But
And
there are tax credits and then there are rebates.
the tax credits, remember that you have to owe tax to get the tax credit. You don't want to confuse that as just something you're going to get back from the federal government or the state. It has to be, you have to owe tax to get that back.
Okay, are you guys going to apply for the tax rebates, Bob, Tony?
Well, we got a $1,000 rebate on the attic system. The basement system missed the qualifying statistic by tenths of a point, and so we didn't get the $1,000 off on that one. But yeah, and then we're going to probably look into the tax credits from federal taxes. So,
Right now, there's something called 25C, which is available as a tax credit. So he can get some money from 25C. It depends on your qualification, as you said, from AHRI.
right.
So I put into chat a link to a Google Doc that is a summary of all currently available building electrification related rebates and tax credits. So if you want to know more, take a look.
Yeah,
Also,
either go directly to the link right now or copy the link or copy the chat.
Yeah, I put it in chat. I can show you if anybody's interested by sharing
well,
screen. Would that be helpful?
Bosa, how did you get to that 0% financing? Like, can it?
We applied
Yeah.
for it. Arctic Air sort of really took care of everything but the actual signing the documents and stuff. So yeah, we got 0% on that. We got 0% on the windows, and we got 0% on the insulation.
The windows is a 1
You know,
year.
also JCP&L and PSNG have special offers for 0% on various things. So that's a good source. So on the screen, you'll see a summary of tax rebates or rebates in New Jersey from utilities, and also tax credits in the center column. The rebates on the right are reserved for LMI. Gee, I'm sorry. Let me get there. Families, but they won't be available for a year.
Okay.
So you can store that on your own if you look at the chat, copy and paste the link. That's all I had for tonight. Thank you for joining us.
Thank you.
Yeah. Thanks, Steve.
Great comment.
Goodbye.
Very good.
Everyone
Bye.
have happy holidays.
Happy
Yeah,
holidays,
Happy
everybody.
New Year.
Celebrate as
Holidays.
many
Yeah.
as you can.